Okay, so we're gonna do a 5.2. It's about infinite series. Or some other book just indicate just a series, okay? So infinite, we see the infinite, keep going, right? Series. So what's the series then? Series is the sum of sequence, okay? So series is sum of sequence. So we learned about the sequence last time, right? Okay, then how looks like a series? Series looks like that. We have this notation, and from n to the 1 from the infinity. So we call this is summation in math. In Greek, we denote this one as sigma, right? Uppercase sigma. Lowercase sigma is like that. No, there's delta. So sigma. Sigma is like this. Easy, right? Okay. All right. Because I'm teaching statistics and we're using sigma all the time, and one of us I don't remember. Okay. So S of n. So how do we indicate this one? We have a summation, means we add each term, okay? So a sub 1 plus a sub 2 plus a sub 3, infinity many, right? So a sub n and so, right? Okay. Now, we're gonna learn the terminology, which is partial sum. So it's the infinitely many series there, many sequence, because sum of sequences, which is sum of the terms, right? We have partial sum. We denote it this way, a sub k, right? Partial sum, which is sigma from n to the k. So a sub n, look, this will be, I should not use a sub n here because we already have a sub n there. So let's make a dot, dot, dot. Okay, then look, this one, we just make a partial sum from a sub 1 to until a sub k. So index, we call this as index, right? So index. So this is also index, right? Okay, from 1 to k, can you see that? 1 through the k, all right? We call this as a partial sum. So here, kth partial sum. All right, then if we say that the partial sum converges to some number, then we can say that whole series converges to the number, okay? So let me write down. Note, if the partial sum, let me just write down partial sums converges to S number, okay? Then the whole series from 1 to infinity, which is S sub n equal to, also converges, okay? So converges. How are you? It's okay. All right. If partial sum goes to divergent, then we can say that the whole series diverges as well, all right? If the sequence of a partial sum diverges, so we have the divergence of a series, okay? So we have an infinite series, then series is sum of all the sequences. Then we take the too many. That's why we take the partial sum. Now we talk about the converges, diverges. The partial sum goes to converges, means that get the sum number, right? A number. Then we can say that the series converges to the number, right? Then if the partial sum diverges, then the whole series is divergent. Make sense? Okay. So we're using that. New location. What do you mean new location? I am the same location.
Oh, sorry, this was a message for Joe.
Okay. All right. So evaluating limit. All right. Use the sequence of partial sums to determine whether the series converges or diverges. Okay, so we have a series from n equal to 1 to infinity. This is a series, right? And n over n plus 1. Okay, now we're going to take the partial sum. Okay, so from 1 to k, but we're not really until k. Okay, let me show you some. So S sub k, right? We say that as a partial sum here. So there will be partial sum. Let's say that S sub 1, which is n equal to 1. So we have 1 over 1 plus 1, which is 1/2. Yeah. Now, S sub 2, which is we have 1/2, right, from the S sub 1, plus we're going to do that again, which is 1/2 again. This S sub 2, right? Then S sub 3, we have, how much we get this one?
Why isn't 2 over 3?
Oh, sorry, yeah. Made a mistake. Sorry about that. So we have n equal to 2, so 2 over 3, right? Thank you. We have a 3. Then what's this number? Let me just write down this number because we don't know, right? Then n equal to 3, then 3 over 4. Okay. Then S sub 4, we don't know the number, so let me write down. Then we're doing 4. So 4 over 5, right? Okay, so how can you say this one? Is the converges? then must be go approach to some number, right? Diverges, keep going infinity, right? So what can you tell?
Is it approaching 1?
Approaching to 1. Okay, so we have, this is a 0.5.
Oh, wait, never mind.
How about this? This is a sum, right? How much do we get this one?
Oh, yeah, it's
Oh, we
just
got
1.1617. How much we get? 1.916. How much we get this one? 2.7.
Why
Is it
isn't 1.92?
9.2? Okay, 9.2.
Because the 3
Okay.
over 4 0.75.
Thank you so much. Yes. So what can you tell? 0.5, 1.17, 1.92, 2.7. We keep doing that until K, right?
we got it. Yeah, infinity.
Yeah, we go to, this one goes to infinity, so we say that diverges, right? So diverges. Diverges. So we call this is unbounded. So unbounded means there is no bound, like 1 is bound and then going to the 1. It's not. So means that keep going, right? Think unbounding means think goes infinity. Okay. Since the partial sum is diverges, we can say the whole series is diverges. All right. So let me just say that the series diverges. Okay. Now let us do this. Okay, so when the partial sum, right? So when 1 equal to 1 equal to 1, and when n equal to 1, partial sum. So -1, 2, when n equal to 2, it's a sum. So don't forget the -1 there, plus
Yellow.
1, which is 0, good. We have S3 partial sum.
-1.
0 minus 1, yeah? Correct?
Yes.
-1. S4.
Yellow.
We get 0 again. S5. They don't have that.
-1.
-1 again. Okay, so -1, 0, -1, 0, -1, 0. So we had the experience the last time, right? So what can we say that this one?
Does not exist.
Yeah. So it doesn't exist. They said that this one. I want to say it does not exist better. But then they has only 2 terms, right? To definition. Converges if they approach it to a number. diverges. Okay, so diverge seems like it does not exist in this book. All right. So normally we call does not exist, right? So -1, 0, -1, 0, negative, right? So say diverges. Or does not exist. Okay. Since alternatively. Changing. -1, 0. Okay. Does the series diverges as well? Okay. All right. So third one, we have the series and from 1 to infinity, 1 over n plus 1. Okay. Oops. Okay, now. Look, partial sum is a 1. N equal to 1, so we have 1 times 1 plus 1, which is 1 over 2, right? It's a 2, which is 2, so 1 over 2 times 3, which is 1 over 6. It's a 3. We get 1 over 3 times 3 plus 1, which is 3 is 4, which is 1 over 12, right? It's a 4, 1 over 4 times 5, right? We have a pattern there. So what can you tell about this one? Oops, 1 over 20.
Oh, it's approaching 0.
0.
Approaching to 0? Ah! Mistake! What's a mistake? Oh my gosh, mistake, huh? What did I miss?
A.
Yeah, we miss the sum, isn't it?
Yeah.
Yes.
Oh,
Yeah, it's the sum.
Maybe
Yeah.
the same question with the number A.
Number 8.
Yeah. The same question.
Where's number 8? Which number 8?
he means the letter A.
Letter A. Oh, did I? Hold on 1 second. No, I did. Yes?
Yeah, the same problem.
Yeah, same problem, yes. But I did in the here, right? But then I did not do. I see what you meant. Why same problem, right? So this is n over n plus 1, then there's 1 over n and n plus 1. It's a little bit different, right? Whew. Okay, then I need a little bit cheating. 1/2, then we get 1/2 there. Plus 1 over 6, right? Now, can you please calculate? And, what should I do? So I can do like this. Okay.
At the point 0, 0.6.
Okay, now, can you please calculate?
0.75.
75 and then 78. And this is 12. Okay, I fixed everything. Now, can you please calculate?
0.8.
0.8, right? Okay, so,
Approaches
Yeah.
infinity,
ah,
goes to infinity.
aha. Maybe one more then?
It goes to 1.
Yes.
Mm. Because it's
20?
going up. Is it going up by smaller increments every time? So
Yeah, but it will never go more than 1. Maybe.
That's correct. So we have a 6, right? So can you please calculate the point 0.8 plus 1 over 30?
0.83.
0.83. Okay. So this one converts to 1. Okay. Okay. Now, since the partial sum converts to 1, okay, then we can say that the whole series converges. Okay, now we have a property about the convergence series. So let me bring the screenshot here. Um, 3.2. So addition is the convergence, then we can split the sum rules, and we have subtraction. We have the constant rule. So we can take out from the series here, okay? So we can do that. This section, they don't have much about this, but we're gonna use entire this chapter, all right? Okay, so we're gonna learn about the partial sum, and we're gonna learn geometry series, harmonic series, and telescoping series, okay, for this section. All right, so geometry series. We have the form of geometry series. So series, we have sum, right? So sum looks like this: a plus ar plus ar squared, ar to the third power. Then we say that this is summation because addition there from n from the 1 to the infinity. Now we have ar to the n minus 1, okay? So other book indicate that this one, n equal to 0 to the infinity, a r to the n power, okay? So this book using the n minus 1 power. Okay, then we call r is the ratio, a is just number. A is number. More specific is initial term in this case. And r is a ratio, which is a fraction, right? All right, so example of a geometry series looks like that. So summation, we have n from 1 to infinity. We have 1 over 2 to the n minus 1. So when n equal to 1, we get 0 power. So n 0 power is the
1.
good. Now you remember. And when n equal to 2, we get 1/2. When n equal to 3, we get
1 over 4.
very good, and so on. All right. Okay, now let me prove. We have this definition. This is a geometry series definition. So this is what I wrote down earlier, right? And look, they say that if the ratio r with absolute value, right? That means we don't want the negative, right? So sometimes r is a negative, then we take the absolute value. Then even though we take the absolute value, that is less than 1, we say that the series converges, all right? Then converges to where? This is how we find the number, okay? Converges to this number. All right, then they say that if we take the absolute value less than or equal to 1, then series divergent, okay? So look, less than 1 means, think proper fraction, right? So example like 1/2, right? Or 3 over 4, like that, okay? Okay, so let me prove, assume r is not equal to plus minus 1, okay? So r equal to plus minus 1, then we say that there is a divergence. Look. So, 보셨어? n equal to 1 to the k a r to the n minus 1. And this one I'm gonna just rewrite as a sum. So the first one n equal to 1, so a plus, I don't have to calculate, just rewrite everything, right? Then we get a r to the k minus 1. So let's just assume r is not equal to r is not equal to plus minus 1. Okay, if r equal to plus minus 1, then we get divergent. So you might think summation equal to 1 to the k. Or one to the n minus 1, right? Okay. This is okay, then let me start. We have this, right? Then I want to multiply by 1 minus r, both sides. So we have 1 minus r, and we get 1 minus r there. Where should I write that? It's k equal to, and then a plus ar plus until ar to the k plus minus 1. Okay, now look, a is the factors. Every term has a, right? So I want to factor out with a. So we will have a, then 1 minus r. There is 1 plus r squared until r to the k minus 1. Okay, now I want to distribute this, right? Okay, then this will be, my eyes, I need to open my eyes. This will be same as, right? So this will be 1 plus r squared plus until r to the k minus 1, right? Now, second term, we do times like that. So this will be, sorry, there is no space to, let me move. Okay, so like that. So this will be negative r.
Negative.
So it's a negative, let me see.
Yes.
Okay, thank you. Negative, look, I make a negative r, so negative r. Then second term is r squared, right? So I want to make a positive, then I make a parenthesis, right? So r squared, and then r cubed until
R the K power.
r to the k minus 1
K.
plus r to the k, right? Okay, now I wanted to show the r to the k minus 1 because we want to subtract, right? All right, so look, we subtract everything, r minus r, right? R squared with the r squared, 3 with the 3, 4 with the 4, and k minus 1 and k minus 1. Can you see that? So we have only 1 minus r to the k left. Okay, then we have from the left side, we forgot about the left side, 1 minus r S sub k equal to a right side, a 1 minus r to the k, right? Okay, now we divide by 1 minus r both sides. Okay, then I think, so that is the from, look, very similar this format. So we have, let me just summarize S of k, which is partial sum. A 1 minus r to the k and over 1 minus r. So we cannot, we already say that r cannot be equal to plus minus 1. So does it here. Okay, so undefined, right? All right, so look, we're gonna have, if the r is less than 1, it's a fraction. Yeah, so think, say r equal to 1/2, right? Then we have 1/2 to the k. So we take the limit, then what this will be?
Yellow.
It's 0, yes. Okay, so we can say that this is a over 1 minus r if the absolute value is r equal to absolute value of r is less than 1. Okay, make sense? So this is the form. They have one here, right? Okay, if then we said if absolute value is greater than 1, then diverges, right? So think r equal to 2, right? So if we have a 2, what do you get this one?
Infinity.
Goes to infinity, right? So
Infinity.
infinity. Yeah, that's why they say that. Make sense? Okay, now geometry series, we're gonna keep using it, okay? So once again, geometry series, the form of like this, okay? I don't wanna go more further. So like that, right? So if n equal to 0, then here is n. So that we can have the first term is 8, right? Now, if they say that converge to where? We have to have a number, right? Then we are using this formula for converging. Make sense? Okay, let us do this. Easy one first, right? So this is the one. We have determine converges or diverging. Okay, so we have the first one, series from 1 to infinity. We have 3 over 2 to the n minus 1. Yeah. So this one, let's say that when n1 equal to n1요. when n1 when n equal to 1, so we get 0, right? It's
Hmm.
what?
1.
Good. Plus when n equal to 2,
3/2.
1, 3/2, good. When n equal to 3, it's 2, right?
9/4.
9/4. Okay, like that. Okay, now what is A in this case?
1.
1. So initial term, right? What is R in this case?
Two.
We have, look, we
3/4.
try. We have A times R. The first term, A. Then second term, sorry, first term is A, the initial term, and second term has A times R. So
Three.
second term we're looking at
3/2.
3/2, right? So we check the third term. So we can say that this is 3/2,
Yeah.
3/2, right? I mean the square. How about that? That is better. Yeah. It's better, right?
Yes.
Okay. So R equal to 3/2 because third term said AR to the second power, right? So let me write down here. A times R, AR squared, right? Make sense? Okay, then we have positive, so we don't actually need the absolute value, right? Already positive. So how can you determine this one is greater than 1? We call this is a divergent. Now I'm gonna say that by geometric series. So GS is okay. Since R is greater than 1, okay, look. R is greater than 1 or equal to 1, the series diverges, okay? So we're gonna say that by geometric series, it's diverges, all right? Okay, second one, we have, let's see, a very similar one. Oops. Okay, look. When n equal to 1, we get 3, right? When n equal to 2, we get,
3/2.
how about this, right? When n equal to 3, 1/2 squared. How about that, right? It's better, we see, right? So what's the A in this case?
A
Three.
screen.
What is that?
3.
3, good. R equal to what?
Half.
1/2?
1/2. Yeah.
Good. So is it diverges or converges?
Converges.
Converges because R is there's already positive. We don't need the absolute value, right? So it's less than 1. So we say that converges by geometry series. Then converge to where? So we're gonna find out. Okay. So that is. So we say that the series converges and the sum is, we call the sum. A over 1 minus R. So A in this case, 3/1 minus 1/2. So we have a 3/2, so 1/2. So we get, which is 3 times 2/1, which is 6. Okay. So converges to 6. All right. Make sense? Okay, now harmonic series. Oh, telescoping. What happened to harmonic series?
Professor, I just have a question. Could you explain one more time, just quickly? How did we get R?
Or
Yeah.
by the definition, look.
Oh.
A times R. A times R
Okay.
squared.
Oh, yeah.
Okay.
Yeah, now makes sense.
So the first term is A, second term is A times R. Okay. So let me see. A and R. Can you see that?
Yes, now makes sense. Thank you.
R squared. Okay, good. Oh, I'm missing harmonic series here. So harmonic series. So let's go to harmonic series. So we have a name of series. So we learned already geometry series, right? So harmonic series, the name of a series looks like that. Harmonic series. Look, we have a summation n from 1 to infinity, 1/n. So it can be any constant here, but the form is something n in the denominator. We called harmonic series. Okay, then I just want to extend this sum. So when n equal to 1, so we have 1. When n equal to 2, we have 1/2, 3, 4. So what can you say this one?
Is it approaching 2? Or no. Yeah. Is it approaching 2?
Approach to 2. Okay, let's see. Okay, S of 1, right? S of 2, I don't make a mistake, 1 plus 1/2, which is what?
Just 1.5.
1.5, good. S of 3, which is 1.5, and plus 1/3. What do you get? 1.5 and 1/3.
1.83.
Thank you. So 1 plus 1/2 plus 1/3. Okay.
1.
It's what?
2.08.
Yeah.
Yeah, it's the same.
Okay, so keep going, right? So now what can you say?
It's 348 as more 5. It approaches
Approach it to what?
infinity.
Infinity is diverges. So it's infinity. What is called? It approaches divergence. Okay. Thus, the series diverges as well, right? So harmonic series, other version, it can be any number. So C is any number. Okay, so we call diverges, all right? Because number is getting bigger. All right. Now we're gonna do telescoping. So we learned geometry series, we learned harmonic series. So harmonic series, we just did that. It's diverges because partial sum going to the approach to infinity, right? So the series is diverges as well. Geometric series, we have the special form of geometric series. Then we check with just R, which is a ratio, which is a fraction, right? Then that fraction, the ratio is smaller than 1, then converges, then converges to A over 1 minus R, diverges if the ratio is bigger than 1. If there is negative, we take the absolute value, all right? We learned geometry, harmonic series, and then partial sum, right? Now, telescoping series. So telescoping series looks like that. Oh. So this one. So we have this series. We've seen this one before, earlier. Does anyone remember this one?
Yes.
Yes.
Yes, very good. So what did you remember? This is a convergence or divergence? You don't remember. Okay, we're gonna show you. We're gonna show that one more time, right?
Divergent.
Converges to 1.
Ah, thank you. Good memory. Good. It's a convergence to 1. So we're gonna show you one more time here. So look, by partial fractions. So we have 1 over n plus 1, right? It's a multiplication, so we change that. So this will be n plus 1, right? So we make a common denominator, then we have n and n plus 1 there, right? Make sense? Then we want to know about what's the numerator. So we did a and b, right? Okay, then this will be common denominator, which is a and a so l n plus 1, a n plus 1 plus bn, right? We had it earlier in the partial fraction decomposition part, right? So then look. So they are denominator identically same. So we're gonna say the numerator equal to 1, okay? So we have let me distribute. So a sub n, let me write down this way. 1 equal to a sub n plus a plus bn. Okay, look, this one will be a plus, let's take out the n term like that, right?
Yeah.
Okay, so this one constant term, there's no n term. So a equal to 1, right?
Oh, one.
Then we have a plus b equal to 0, right? Because there's no n term. Yeah, no n, right? So since we have a equal to 1, b equal to -1, right? So then look, we have come on.
One over n minus.
Ooh, copy. So we have this. Okay, that will be 1
One.
over n
N
minus 1 over n plus 1. Yeah, okay. Look, then this will be sum n equal to 1 to infinity. We have 1 over n minus 1 over n plus 1. Okay, when n equal to 1, it's a 1 minus 1 over 2, right? Plus, when n equal to 2, 1/2 plus 1/3, right? Now there is a pattern, right? So when n equal to 3, we have that. Okay, look. Then if we take the partial sum, right? Partial sum from n equal to 1 to k, then we're gonna have 1 over n minus 1 over n plus 1. So we will have, look, same as the above. So 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 until k term. Can you see? 1 over k minus 1 over k plus 1. Yeah. Sorry, no space. Okay, then look, we can simplify here. 0, right? 0. So we simplify everything until 1 over k, right? Then what's the remain? It's a plus. The remaining only first term and the last term, right? So this will be 1 minus 1 over k plus 1. Okay, now let's take the limit. What do you get?
Below.
So it's a 0, right? So we get, this is 1. So it's a converges. So we had earlier, when we talk about the partial sum, right? So we said that, oh, this is partial sum goes to converge to 1. So the whole series converges, right? Make sense? Okay, then let us do one telescoping. And then I wanted to mention one nth term test, but then maybe we do the nth term test next time, right? So let me write down telescoping series definition. So a telescoping series is a series in which most of terms cancel in each of the partial sums, leaving only sum of the first terms and sum of the last terms. Okay, so one more telescoping, then we're done. So we have determine converges or diverges. Okay, we have the series cosine 1 over n minus cosine 1 over n plus 1. Okay, so if it converges, then find its sum. They say that. So let me write down. If converges, find its sum. Okay. All right. So partial sum. Maybe we can make a partial sum, right? So S sub k, which is that k equal to 1 to, I'm sorry, n equal to 1 to k. All right, so cosine 1 over n minus cosine 1 over n plus 1. All right, so cosine n equal to 1, so cosine 1, right? And n equal to 1, cosine 1 over 2. And plus, when n equal to 2, we have a cosine 1/2. And cosine, we have a pattern, right? 1/3. Plus cosine 1 over k. And cosine 1 over k plus 1, right? All right, then we can simplify everything until we get cosine 1. And we have a cosine 1 over k plus 1. All right, so think limit k approach to positive infinity. What do you get this one? What about inside?
1.
It's going to 0, right? So it's
Yeah.
1. So
So just
Yeah.
Below
yes, so it's 1.
1.
Good. All right. Then we have cosine 1 minus 1, right? Cosine 1 is number. So what do you get? Can you please calculate? Cosine
0.54.
0.54.
0.03.
Okay,
Negative 0.46.
negative 46.
I got that.
Okay. Okay, negative 0.46, that's correct?
Yes, that's correct.
Okay. All right, good job. Thank you for coming.